Okay, I'm making this recording of a PowerPoint presentation to help you prepare for the socrative test for LV13K, which is transmission, level 3 transmission systems. So the first slide here is, it says you need to be able to describe the symptoms of and the possible causes of the following: clutch drag, clutch slip, and clutch judder. Okay, so what that means for clutch drag, you need to be able to describe the symptoms of it. In other words, recognize what your customer would be complaining of as a fault. When they describe the fault, you need to be able to recognize those symptoms, so that you know that they're talking about clutch drag, because the customer won't necessarily know that. You also need to know what causes clutch drag. Alright, and there are several different things that could possibly cause that, but just have an awareness of it. Same for clutch slip. Alright, you need to, when your customer comes and describes the fault, you need to be able to recognize what they're telling you as being clutch slip. Alright, and again, you need to be able to identify what might cause a clutch to slip. And the same with clutch judder. Okay, I think you get the idea there. Let's move on to the next slide. It says here you will need to be able to identify which combination of gears work together to create first, second, third, fourth, and fifth and reverse ratio using the diagram below. It says below, but it obviously is next to it on this PowerPoint. So basically, this is my input shaft. Right, so these are the input gears. This is the output shaft. Alright, and this is the final drive. So we've got the crown wheel there, the differential in the middle, differential gears. We've got two CVs, inner CV, one there and one here, and the two drive shafts. There's a drive shaft and there's another. This shaft here is the linkage that goes to the gear lever inside the car, so it's the gear lever linkage. Right, what you've got to be able to do is recognize which two gears are first, which two gears are second, etc., etc. As a general rule, lost my cursor. As a general rule, the gears at this end of the gearbox would be the higher gears. Right, so right at the far end would be fifth gear, and at this end, it's generally they're the lower gears. So first is at this end and fifth is at this end. But just make sure that you're familiar with that diagram in particular, because they use that diagram a lot. Okay, next slide. You need to be able to name the component parts of an epicyclic gear set. Alright, so epicyclic gear sets are also known as planetary gears. Alright, because you have the sun and planetary gears. Okay, so this diagram shows component A, B and C. So I'm going to start with B because it's in the middle. Alright, and if you think about what's in the middle of our planetary system, it's the sun. Alright, so this gear here, B, alright, is referred to as a sun gear because it's in the middle. And again, if you think about our planetary system, you'll know that this gear here and this one here represent planet gears, and as I say, you know that the planets go around the sun. So there's the clue. The one in the middle is the sun gear. The ones going around the outside of the sun are called the planet gears. So this component here, component C, which holds this gear and this gear, is called the planet carrier. Alright, so B is the sun gear, C is the planet carrier, and A, which is the component that goes around the outside of this cluster, it looks like a ring, so the Americans often call it a ring gear. The other technical name is the annulus. Alright, so A is the annulus, B is the sun gear, and C is the planet carrier. I've added another little question down here. If you held C so that it couldn't rotate, So if we hold the planet carrier, all right, so that it doesn't rotate, right, doesn't mean that the individual gears at the end here, these will still spin, so the planets will still spin, just that the planets won't go around the sun. So if you held C so that the planet carrier can't rotate and turned B clockwise, which direction would A turn? So if the sun is going clockwise, then the planet will be spinning anti-clockwise, which means that the annulus or the ring gear will be going clockwise, the same direction as the input. Now generally, again, what you need to know, generally your input gear for all forward gears goes the opposite direction to your output. So the input and the output are opposite each other. Now in this scenario that I've just described here, the input and the output end up both going clockwise. So if they're both going the same way, that's unusual. It would mean it's going in reverse. All right, so there's a clue there. You need to know about how you work out reverse gear. Okay, let's move on. Next question, or next slide, sorry. You need to know that Incact stands for electronically controlled automatic transmission. Now in the classroom we've talked about various electronically controlled transmission systems. The one that I've made a lot of reference to is Volkswagen's DSG system. DSG stands for direct shift gearbox. You know that in these electronically controlled systems you have lots and lots of sensors that monitor things like the input speed of the speed of the input shaft. Compare that to the speed of the output shaft. You can work out the speed of the output part of the clutch, so you can work out whether the clutch is slipping or not, or the computer can work out whether the clutch is slipping and can then control actuators that engage the gears and engage the clutch at an appropriate rate. Okay, so as I say, the important thing here is that you recognize this abbreviation. Incact stands for electronically controlled automatic transmission system. Let's move on to the next slide. Okay, another abbreviation here, CVT. You need to know that CVT stands for continuously variable transmission. You need to have a basic understanding of the construction and operation, so I've put a video link here. Just going to freeze that for a minute, stop it for a minute. Yeah, by all means watch the whole video. I have shown it to you guys in class before, but I'll leave it there and I'll send a link in a separate email. Another question down here, does a CVT or continuously variable transmission belt transmit drive from one gear to another by pushing or pulling? Alright, I'm just going to show you the first couple of minutes of this video, a couple of seconds hopefully, just run that.
Hello, my name is John Kelly and this is the Weber Auto YouTube channel. Today we are going to look at the construction of a CVT, continuously variable transmission push belt. The belt that goes between the two pulleys that I have back here.
Okay, just stop him again. The reason I've shown you that is he made specific reference to the fact that the belt is often known as a push belt. Hopefully that gives you a clue to the answer here. Alright, okay. And just remember that because, again, there may be a question coming up your way. Alright, let's move on to the next slide. Sorry, there we go. Alright, what you've got there is an image of a synchro ring, sometimes known as a bulk ring synchro. It's part of the bulk ring synchromesh, but it's a synchro ring. Just a bit of background info. Basically, when you're trying to engage two gears in a manual transmission gearbox, the input and the output speed are going to be different, and in order to engage the gear, you need to synchronize the speed of those two components so that it doesn't crash or crunch when you try to change gear. So this component here acts a bit like a brake to slow one of the gears down so they synchronize their speed. Okay, it's made of phosphor bronze. Alright, so it's softer than the gears themselves. Alright, so think about your brakes. Right, you have a hard brake disc, but you have a, relatively speaking, soft brake pad. The idea is that the pad will wear out before the disc does. So the same is true here. This component, the synchro ring, is made from phosphor bronze, so that it's designed to wear before the gears wear, because replacing the gears would be hugely expensive. Now, as I say, it's meant to act a bit like a brake, or does a similar function to a brake, but you need to bear in mind that inside the gearbox it's full of oil, and the oil is going to reduce the friction. Alright, so the idea is when two gears are squeezed together, these grooves in here, so this big groove and these smaller grooves, are in it to allow the oil to disperse and squeeze out. So when the gears are squeezed together, the oil squeezes out through the grooves and allows friction to be created. Okay, so that's a synchro ring and it has grooves in it. Make sure you understand why they're there. Let's have a look at the next slide. Okay, we've got first, second and third gears are known as reduction ratios. Fourth gear is a 1-to-1 ratio, so that means that for one turn of the engine crankshaft, you will get one turn of the output, your gearbox output shaft. Alright, and it also says that fifth is an overdrive ratio. So first, second and third reduce the output speed but increase torque. So we know that if we want to go uphill, the steeper the hill, the lower the gear. Alright, so first gear will increase the amount of torque that's available to get us up that hill. But you guys know that when you're in first gear, the output speed of your car is generally slower. So you, first gear, first, second and third all reduce the output speed but increase the torque. Alright, fourth gear is 1-to-1, so for one turn of the crankshaft you get one turn of the output shaft. So then the next question here is, what does an overdrive gear ratio do? Alright, so fifth is an overdrive, and basically it shouldn't be too difficult to work out. I'm going to tell you anyway that an overdrive is the exact opposite of a reduction ratio. So it would do the opposite of these. An overdrive will increase the output speed but reduce the torque. Okay, I think that's good. Move on. Okay, we also need to know about automatic gearboxes, conventional automatic gearboxes that have a torque converter. So you need to be able to identify the main component parts of a torque converter. And the IMI use this diagram a lot. I don't really like this diagram, but anyway, that's the one that you guys need to be familiar with. So you need to know that the main component parts are A, the impeller, B, the stator, and C over here is the turbine. Just to try and explain this diagram, so your impeller here is has a metal connection welded to it that this line here represents. Is actually in real life it's the casing of the torque converter, and that is effectively bolted to the crankshaft. So the impeller, it's a big heavy piece of metal, does the job of a flywheel that you would find on a conventional manual transmission system. Okay, so your engine will be over this side. The flywheel, it's not called a flywheel on these, but the job of the flywheel is done by the impeller. This central bit is the stator, and this part over here is the turbine. Now the turbine, if you follow this line here, you can see it's connected to this shaft here, which is the input shaft into the gearbox. So the C, the turbine, transmits torque into the gearbox. Basically, make sure you're familiar with this diagram make sure that you can name the impeller, the stator there, sorry, and the turbine. That should see you right. Okay, I don't think I've got any more slides. So armed with the information you've got there, you should be able to get through the test. There's going to be about 30 questions on the test. As I say, I will launch it over the weekend. I'll email you details of how you access it. I'm going to leave it running all weekend. I'll check it on Monday. I'm going into college on Monday, and at some point I hope to close it down. So I would like you to try and get this done over the weekend if you could. If you have any major problems, email me. I have to confess I won't be checking my email that regularly over the weekend, but certainly I will be checking it on Monday, and I'll get back to you if you have any major problems. Alright. Okay, good luck, and I'll see you on the other side. Okay, as they say. Alright.